Hey everybody, this is Larry. This is me doing a random problem here on April 11th. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's random extra problem thingy thing. Today's extra random problem thingy thing is 798, smallest rotation with the highest score. You are given an array nums, you can rotate it by a non-negative integer k so that the array becomes nums of k plus 1, dot, dot, dot. Okay, so just a rotate. I read it out loud. Sometimes I read things out loud before my mind kind of interprets it. Actually, when I read, like during a contest, when I read, I don't read it out loud. And I think, I don't know. I'm not, I don't know. There are two processes for me, I think, or something like this. Anyway, that aside, afterwards, any entries that are less than or equal to the index are worth them one. Equal or to the index are worth 1 point. For example, we rotate by 2. This is 3 points because 1 is greater than 0. 3 is greater than 1. 0. Okay, it's less than or equal to the index. So okay. I have to kind of really think about what it means, but that's fine. Okay, so n is 10 to the 5th. Return the rotational index k that gives us the highest score. Okay, so I mean n is 10 to the 5th, so we try every k naively, it is going to be too slow, right? The question is, how can we do it a little bit smarter, right? The first thing I want to do, right, is maybe rephrase the problem. I don't know that this works, by the way. I'm not gonna lie. Like, I'm not trying to be like, oh yeah, of course, you just do A, B, and C, and then da 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 da. You know, this is a problem I don't know how to solve right now, as of this moment right there. And I'm looking down because I'm pointing out that, or I'm trying to find my notebook so I could point it out that usually I would write it out in a notebook and maybe just play around with small examples, but I would do it on the screen instead. One thing that I have an idea about is just converting the indexes to, or the numbers to be corresponding to the indexes, because that way then we can just count the number of positive numbers, or maybe negative, something like this, right? Or 0, but we can just count the number of those numbers, and then maybe we can do something of a shift, right? For example, let's say we have this thing, right? So now if we, and I would do this manually maybe, because let's just do it manually, right? So then now maybe I would convert this to say, what is it? I always forget which direction is for this part, but yeah, so let's say the index is going to be 0, 1, 2, 3, 4, 5, or no 5, sorry. So then it's going to be one of the numbers subtract from the other numbers. So so maybe this is right, maybe I want it the other way. It doesn't matter, right? It's just the absolute value, or multiply everything by -1. Not a big deal, but that's the way I want to think about it, right? And then now, okay, so I did get it wrong because this is score 2, right? And you can, sorry, give me a second. Okay, so I have it the other way, right? So now here you could say -2, and then 1, -1, and 4, right? And the reason why we want this is because then now you can see that this score is 2 because they're two positive numbers, right? And and I like to kind of do it this way, and you may ask, why are you doing this? Because I had an idea that you can, that it would be cheaper to do this. Because then now we think about rotating. What does the rotating function do, right? Well, we can, there are a couple of ways to think about it. We could do it manually first, right? So then here, which way do we rotate? This way, is it? Right? And then now you have -3, 0, -2, 3, 2, right? So this is 3 because we have 0, 3, 2, right? But I mean that we could do, and of course if we kind of keep doing this for everybody, it's still gonna be n squared. We haven't done anything new. But the interesting thing is kind of relating this thing with this thing, right? And what does this mean? Well, let's rewrite this original thing in the context of the thing. So then now, one way to do k or think about k is just, doing this rotation that they tell you, right? Going from here to here. Another way to do it is just, given the original thingy, converting this to this. Is it this one? No, the other way. Sorry. This, right? Is it? Oh yeah, it is. It's just that this is right, and then now you have this instead, right? Which is still, again, everything's the same, right? But the difference is that now we can compare this with this more directly, and let's take a look. So we have this and this, right? Here, and the thing that you can notice very quickly is that every value shifts by 1, except for the first value. Why is that? Because the first value went from 0 to 4, right? Because the only thing that's different between here is the top of the subtracting, or whatever it's called. Huh. Is that a word? I don't know. Right, so then now you can kind of do the math as, okay, you have this, you have this. So then the delta is going to be, I guess it's the other way, sorry. Right, so it's going to be plus 4, and then -1, -1, -1, -1, -1, right? So that is the delta between these two as well. Okay, so that's two things, right? For me to play, I mean, sometimes I am able to kind of do this with two things, but let's play around with the third thing just to make the pattern more clear, right? And so then now let's do this one, right? So here again, instead of rotating this, I will rotate this number, right? So then we have, so we rotate the 3 to the front, right? And then now, of course, yeah. And now we just subtract this part instead of, did I do this right? Oh, no, this is the original number. Sorry, that's why. I think I confused myself. But I mean trying to go from here to here, right? Okay, there we go. No, I think it's the other way. Yeah. Yeah. Is it? Yeah. Right. So then now, this is -1. This is plus 4. This is -1, -1, -1, -1, right? Okay. Still don't know if this is the right approach, to be honest. But now we kind of see the pattern about this delta map. And then the idea then is to, I'm just thinking about, and this could be totally the wrong way, but this is the way that I'm thinking about right now, is that, okay, given this idea, then now, the first operation is going to have this change, the second is going to be this one, or I guess from first to second is going to be this one, second to third is this one, and then if I have to guess, the next one's going to be, this, right? And so forth. And this is a very easy kind of like transformation that we can do, right? And then the question is, can we do this? And this is the money-making question, which I don't know if I know how to solve, is, okay, can we do this in less than O of n, right? Because I mean, if you take every number and then you apply this, that's not making it O of n, right? That is just, that's not making it O of 1. It's still O of n, and that's going to be n squared. So then now we have to, so rewriting this, now we start with this. We do a thingy here to get, the first one, right? I guess actually it comes out to this, so I could be lazy. Yeah. And then now the next one, we apply this thing to it, right? And now to be honest, I'm just playing around with some ideas, right? -1, oops, -1, -3, oh sorry, this is just 2, and this has 3 things still. I mean, now we're just playing around with some ideas, and I have some ideas. I have to kind of figure out how to tie them together, but the idea would be to to use some kind of a heap, right? Yeah, my idea would be figuring a way to either have some heap or some sorted data structure so that we could get we can do some kind of math, because if we have the min, then we can assume that every other number is just -1, right? Okay, maybe, okay, this is actually another way of thinking about it. Now that I'm thinking about it, right? So then that means that, okay, this is a hard one. So I'm apologies that, I'm not able to, I don't have it. We're all doing it together, so hopefully this is more insightful and more useful than me just like explaining the answer, right? Yeah. Instead of thinking about this as this operation, right, we can think about this as two operations instead, which is -1, -1, -1, -1, and also 5, 0, 0, 0, 0, 0, right? And now, why is that useful? Because this means that we apply this x times implicitly, right? So now we can apply this x time implicitly. That means that on the 5th round, every number is -5, except for the numbers that we added 5 explicitly, right? We add this explicitly, right? And I think this gives us the answer, right? Because now we only have to update one number, and then we can maybe do a binary search or something like this on the rest of the numbers. I mean, I said heap, and maybe that would still work, but for now I'm going to use a sorted list to kind of keep track of that, right? So okay, let's play around with that idea in coding. So, oops. Right, let's play around with this idea in coding. And then for I, x in enumerate nums, what do we want to do again? So it is the index. I like breaking it out sometimes. Index minus x, right? So add index minus x, right? And then now we can do a binary search to get the number of positive numbers, right? Or 0 non-negative numbers, right? So then best is equal to 0, say, and then here we can yeah, we can binary search on 0, and this is the index. What does the index give us? So the index gives us the numbers that are so this gives us the first index of 0. So index gives us the number that are smaller, right? So then now n minus this is the number of positive numbers. So then actually best is equal to, I think this is right, but maybe I'm off by 1, but that's, if I'm off by 1, this is fine. If they're all negative, this will give us the insertion point of n, so this gives us 0. I think that's right. If all the numbers are positive, this gives us 0, which is n, which is right? So that's how I want to prove it. And then now we can play around with, okay, now we assume that every number is subtracted by 1 after I iterations, right? Yeah. So then now, another way of thinking about it is that now we apply subtract 1 to all numbers. This, and then search for 0, right? But that also means that we can also just search for +1, which is ones, or greater than equal to 1, right? That's basically what I was setting up for. That part that part I knew ahead of time, or not ahead of time, but just like 20 seconds ahead of time is what I mean, not like that far ahead, right? So okay, so then now, yeah, but with a change, right? We have to do a +5. So then here we have num sub I, right? We know that num sub I is inside the sorted list. So then here we can do, I forget what is the, let me look up sorted list real quick. I think there's a fine or something like this. There's no fine. Is it just index? I mean, is it just do we do a binary search on it, or is there a fine on it? I guess it's, I thought there was one that's like explicitly no, index is right. Return the first index of the value. what is the, I guess index is the, okay. So there is an actual index, which is actually what we want anyway. I guess that's also a binary search. They both give the same answer, but I think this gives us an error if it doesn't exist or something, right? So okay, so then now let's say index is equal to this. Or maybe not. We don't even have to. Wait. Sorry. Let me check the sorted list API again, because I think there's a remove, but I think one of the removes remove everything, and one of them just removes all of them, and I forget which one is which. Because I made this mistake before, and every time I make this, it is not great. There's remove and a discard, but I don't know which one is. Okay, remove has to be in the list. Okay, that's fine, but I want to see like okay, let's try it. If I make a bug, we know where it is from. So okay, so now we remove this, and then we want to add num sub I plus n, right? This is the 5 that we talked about, so to do this operation. So now we add it back. Then now we can search for, in this case, 1, but it's just I plus 1, right? So then now it is sl.bisect left of I plus 1 and minus this, and then we can update best with it. And I think that's it. And this is one of those problems that, you look at the end result if it's right. Oh, it's not remove num sub I. It is remove the index minus num sub I, which is what we have in the thing. So it's going to be this. Whoops. Oh, then I have to fix this. Whoops. I minus. Okay, hang on. A little bit sloppy, but that's okay. How did I get 4? We'll debug this. But that's fine. Okay, so print SL and also this thing, I suppose. Let me also add I in here. Show me your eyes. Okay, right. So here we have 3. That's right. Yeah, and we're looking for 1 and higher. Here we're looking for 2 or higher, so this is also 3. That's right. 4, 3. Oh, I see. Okay, so right answer, but I returned the score when we're supposed to return the K. Okay, so that, okay, I am just being dumb. Okay, so best, so best K is equal to 0, right? And then this is just equal to this thing, and then okay, so then now if so score is equal to this thing. Okay, so we knock on wood, hopefully we got it, but best is equal to score, best K is equal to I plus 1, I think. Maybe I'm off by 1, but that's fine. Oh, I'm still returning the wrong thing. Too much ego in running the code. But yeah, let's give it a submit. Hopefully this doesn't time out or whatever. It is a little bit slow, to be honest. Maybe there's a easier solution, to be honest, but this is the laziest way that I can think about it. And I think that building off this, there's probably a property, like I was saying, you can use a heap in some way as well, because there are other ways you can kind of hack around it, but you could use a heap. Maybe it's a little bit faster. You could do some like lazy update kind of thing, but that's just complex. It's more complicated, right? Complexity is probably the same. It is lower constant, but I'm actually like a little bit curious what the faster way is, because this is a little bit slower than I would like. But I would also say, just like, you saw me walk through this problem. If you didn't know anything, you look at all this and it is like 20 lines of code, 3 lines of comment, a lot of spaces. So this is way short, and you're like, wow, this must be an easy problem. And you look at someone's beautiful code on whatever, and you're like, wow, this is an easy problem, or this should be easy because I look at this and I understand it. But now, how long have we taken? It's like it's been 20 minutes on the dot, and we kind of worked through all these things just to get there. And to be frank, maybe I'm arrogant in saying this, and okay, maybe I do talk it out more than I would. Like, I would be faster if I'm just like heads down work on this problem and I'm talking it out to you, of course. And I'm arrogant, which is to say that I'm pretty good at this, right? And it still took me that long. So, and I don't mean this to brag, but I mean this to say it's okay to take long and all these things, right? It's not an easy problem. It's what my point is with that comment. But I am wondering if there's a linear time thing. Like I could see some stuff, right? But it's just, I don't know. It just feels so weird. All right. I mean, I what's the complexity here? All the ads is gonna be this is gonna be log n, log n, a log n, two log n's. This is all gonna be n log n, right? So yeah, that's pretty much straightforward, which is why I did it, because I was like, oh, it's n log n, it should be good enough. The time is slower than I would like, so I'm gonna take a look to see if I'm missing some really obvious ones. There is an O of n one apparently. So let's take a look. Okay. Don't know that I understand this one, but I mean, I guess I see what they mean. Oh, I see. So basically, it's just the intersection of good intervals. Okay, I get that. Okay, I see. That's actually pretty nice. So the way that they were saying is that, or I don't know if that's, or this is my interpretation. They actually said it a different way, but they're saying that, okay, I mean, it's the same idea, kind of, or like you could get there with this, with what I have. I don't know. I guess it's not really the same idea, but the idea there is that you have these intervals of goodness, right? For example, here this is -2, it gets added to 5, so now it is 3. So that means that in a way it is not good on the first. Like if you just plot out this one, it'll plot out this number going to from the lifespan. It's going to be -1 -1 plus n -1. So it's going to be some graph like this, right? Let me actually put out some paint. And by sorry, when I say paint, I mean like let me put it on a drawing board, because I think this is a pretty cute solution. I just didn't think about it that way, or like it's the same idea, but I didn't like that's one more step of simplification. But basically, the same idea that I had, which is that, or using the ideas that I have, it's not the same idea. Is that let's say this is the 0 line, right? And here let's say that we start at, I don't know, -2. And then the next one is going to be -3, -4, and then plus n, and then right? So that's like one, or I don't know how far it goes. So that's like one possible look of the graph, and every one is like this shifted in some way, right? Like for every index, it's going to look like this in some way. So then now, with this in mind, then now we can think about it as just intervals. Let me change the color. The intervals of the intervals of positive or non-negative numbers, right? Because it goes here, right? So you have one interval for this one. Let's say you have another thing that goes like, let me draw it like right? I guess the increment is always high, but right? Then now here you have, I don't know if this is a real possible one actually. I think it should be, but I could be wrong. So then now this one you have, this interval and this interval. And then the idea is that now you're trying to find the maximum intersection of the intervals. And in that you can do it in linear time because you don't need to sort, you can do it with a difference array. And if that doesn't mean anything to you, maybe it's a little bit complicated, this one anyway. But yeah, let me show you my code before I go though. I still like the way that I did it though, but that is, I mean, it's pretty cool. Not gonna lie, I just didn't think of it that way because end log end is fast enough, so I didn't really optimize it a little bit more. But yeah, but I was curious whether there's an end solution. But yeah, here's my code. And yeah, that's all I have for this one. End log end time, O end space. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.